Hello, good evening. Okay, so we'll wait for 5 more minutes and then we'll start. Hi, Kamesh. So, in which year you are now currently? Final year? Okay, okay. Hello. Good evening, everyone. I hope I am audible, right? Okay. So, before starting today's session, so a little announcement is there. So, actually, as I have missed that previous live session, so as a compensatory session, I will take 2 hours class on 15th January from 5 to 7 p.m. Just note that time. The next class will be from 5 p.m., not from 6 p.m. So it will be a 2 hours class, 5 to 7 p.m. And in that class, I will cover the few concept as it is going to be a long session. So that's why I am thinking to cover few topics also like regular solution model, free energy versus composition diagram, and the concept of the miscibility cap. And as I will also solve some questions that will be related to those previous mentioned topic also, and some questions related to thermodynamics. And if you people have any kind of suggestions regarding which type of solutions do you want, you can also give me suggestions, and you can also mail me if you want, or if you are facing any problem in any of that any topics or any type of question. So okay, I am also giving my mail ID in the chat box. So if you people want me to cover any other topics or any other questions related to any other topic in which you are facing problem, I will also try to cover those. Okay, so now let's move into the first question of today's. This is the question number 21 of GATE 2015 Metallurgical Engineering. So the question states that the select the correct plot of Gibbs free energy versus temperature for a single component system from the following. So as you can see, the four graphs are given. So any one of you want to approach which one will be the correct answer and why? Okay, you are saying Q. Any other want to answer? Then I will go into the explanation part. Subramaniam, you are saying P. Okay. Okay, so as both of you are have given two different answer, so can you people give some explanation why why you are thinking that this will be the correct answer? So Ajanta, can you explain like why you are saying it is Q, and Subramaniam why it is P? So then I will go. Then I will explain which will be the correct answer and why. So first, at least try to explain why this is why you are thinking so. Yes, so G is H minus T delta S. As temperature increases, entropy increases, enthalpy also decreases. Yeah, so that is correct. Both of you are saying basically that P and Q. If you see the two option in both cases, the free energy is decreasing, right? So as you know that the expression for the free energy is H minus Ts, right? So now when I will plot G versus T graph, so then if you see that y is equal to mx plus c type of equation that is, or so then I will find that your G is y and T is like x. So in this case, your that intercept will be h, and the slope will be minus s, right? But as as h and s both are function of temperature, so that's why that graph are not straight line. Okay, so that's why they are like curve in nature. But in two cases, both the cases like P and Q, your G is decreasing because slope is negative, right? So actually your G versus T graph with temperature G should decrease. Okay, So in the both the cases g is decreasing. So why okay, slope of, yes, so in the both cases this is, it is decreasing. So what you people explained, that that g will be decreasing as slope is negative. So that is correct. But why p, why not q, and why q, why not p? Can you explain that part also? Yeah. So one more thing you can you can see the slope is minus s, right? And how entropy changes with temperature? If temperature increases, let's say T is increasing, so then what will happen to the entropy? S will also increase, right? With temperature, S increases. So that means what should be the slope with temperature? When you are going in the right direction, means in the you are increasing the temperature, what will happen? Your slope will increase, and slope is, I mean, entropy is will increase, and as entropy is increasing means slope will be more negative, right? S is increasing and slope is negative. So with increasing temperature, your slope will be more negative. So now if you see the option p, in here the slope is around like where it will touch, their slope will be minus infinity, and then the slope will increase in the positive direction, and it will go to the zero at here, somewhere here, right? So that means if you plot the dg versus, or the slope s versus t, means like in this case for this graph, slope is like here it is changing, and then uh, it is decreasing in this direction, right? But in, okay, sorry, it is going to zero somewhere, like, and in this case what will happen, if let's say this is the zero, so this is here, somewhere here, where it will touch at h, here slope is 0, and then here it is going to minus infinity. So in option p, your slope is changing from minus infinity to 0, and in option q, slope is changing from 0 to minus infinity, right? So that means uh, with t what should happen? With t your slope is going to be more negative. So if you see in the option q, here you can see that with temperature, with increasing temperature, your slope is going into the more negative direction, right? So in this case your correct answer will be option q, not option that not p. Okay, so this is wrong, as both the cases g is decreasing, but you also have to see how the slope is changing. Slope should be more negative, because as you are increasing temperature, your entropy is increasing, so slope is going in the more negative direction. You know, right? At t is equal to 0 kelvin, that means as at absolute temperature, it is assumed that entropy is 0, right? And then as you are increasing temperature, your entropy is increasing. So slope, what will be the slope at t is equal to 0? Your slope will be 0, and then it will increase in the negative direction because the slope is minus s. Is it clear to everyone? Okay, so do you have any other questions, any questions or any doubt related to this question? Okay, okay. So if everyone is clear, so I'll move into the next question. So the next question is also related to this concept only, but uh, yes, Arjun, what is your question? Graph between H versus T. Okay, that also I have explained earlier also, but if you want, I will explain again that graph versus G and T. So let me add one new slide. Huh. So So that exact enthalpy that people cannot measure. Okay, so people generally measure the change in enthalpy. Okay, so that's why as a reference it is assumed that at room temperature or as 298 Kelvin. Okay, so the enthalpy is assumed to be zero. So let's say this point at 298. So this is your H, and this is your temperature. Okay, so this is a zero, y zero here. Okay, so it is assumed that at 298 Kelvin, that reference as a reference, your enthalpy is zero, and then it increases with your temperature. So this will be the shape of your enthalpy versus temperature. Okay, and what will be the shape of the S versus temperature? So at absolute zero it is zero, and then it increases, and at some temperature after sometimes it saturate. So you will get some S kind of shape in case of entropy versus temperature, and this is enthalpy versus temperature. Is it clear? Okay, so so now let me move to the next question. This is the question number 31 of GATE 2017 Metallurgical Engineering. So the question states that T1 and T2 are the melting point of pure metal A and pure stoichiometric oxide AO2 respectively, and temperature that T1 is less than T2. The stoichiometric metal oxidation reaction is given, that is A in the solid form is reacting with oxygen in the gaseous form and forming AO2 in the solid form. So is in equilibrium at 1 atmosphere pressure at temperature less than T1. So now if the temperature increases, which schematic represents the correct standard free energy change versus temperature plot? So four options are given. Okay, so you have basically pure metal is oxidizing, presence of oxygen in gaseous form, and it is forming AO2 in the solid form. So what will be the, sorry, so in this case what the delta G you can write as delta H minus T delta S. So in this case also, in the plot of G versus T, what will be the slope? Slope is minus delta S, right? So now what will be the delta S here for this reaction? Delta S will be S of AO2 minus S of A plus S of O2, right? So now as you can see, S of O is in the gaseous form and others are in the solid form. So what will be the entropy sign of the entropy change? It will be negative, right? Because this value is higher as compared to this and this value. So your entropy change delta S will be negative. So if delta S is negative, delta S is negative means your slope is uh, it may not be exactly zero, but that value will be very negligible in case of, because in case of solid also you have configurational entropy, right? So entropy has two terms. One is configurational, and another is your uh, thermal entropy. So only entropy is considered to be zero at absolute zero temperatures. That is uh, at your T is equal to 0 Kelvin. But at any other temperature, you will still have some thermal entropy and some configurational entropy. Still at that 0 Kelvin temperature, your configurational entropy will not be zero. Okay. So, but the thing is that the order of that value will be very high in case of gaseous form, but in case of solid form that value will be very negligible or considered to the gaseous form. So basically your S of oxygen is much greater than S of AO2 in the solid form. Yes, exactly. For the gaseous form, your entropy is highest, and then liquid, and in the liquid form, and then in the solid form. Okay, so that's why the sign of your delta S will be negative in this for this reaction, and as the sign is negative means slope is positive. So what should be the shape of the curve then, or shape of this, which is representing the correct standard field energy versus temperature plot? Anyone of you can answer? I have already given some hints. Okay, so you are saying option C with question marks. That means you are not sure. Any other one to answer? So some hint already I have given. So then now you need to think a little bit and then try to answer. So Achanta, which option is correct? And comments also, you also can try to answer. If you are wrong, still it is okay, but at least you people try to answer. So then at least think in some direction. So it will also help you to approach the question, like how to approach this. So as already I have given some hint, slope is positive. That means your what will be the delta G versus T graph, or that will be uh, the it will be in the increasing trend, right? At every section it should increase with temperature. So now as you can see in the option A, initially it is increasing, but now it is decreasing. So that means slope is positive here, but negative here. Okay, and again positive here. So this option will not be correct, as the slope is positive. Okay, for this reaction, because in this side you have gaseous form. Okay, so again if you see here also slope is positive, here also slope is positive, but slope is changing after T1 and T2. Slope is changing in this case also, positive, 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 but slope is changing. And in the last option also, first slope is increasing, then also it is increasing, and then it decreases. So here also slope is negative. So in both the option you can discard. So either it will be option B or option C. Now what are the difference in option B and C? So you can see that uh, this is T1. T1 means melting temperature of A, Tm of A, and T2 means Tm of AO2, right? So let's say you are at below T1 somewhere here. Now you are increasing your temperature. So when it will reach the T1, what will happen? So I'm writing the reaction again. So at below T1, sorry, and second one is at above T1 but below T2, and third option is above T2. So what will be the difference between the reactions? So below T1, your A is in the solid form, plus oxygen in the gaseous form is forming AO2 in the solid form. So now when you will above T1 but below T2, what will happen? Your A will be in the liquid form. Now it is not in the solid form anymore. Okay, so it will transform into liquid form. So now, and oxygen will be in the gaseous form, but as you are below T2, so your AO2 will be in the solid form. Okay, and what will be the above T2? Above T2, your both A and AO2 will be in the liquid form, right? Because as the vaporization temperature of A is not given, so we will assume that in this case below above T2 also A will be in the liquid form. Okay, so now you can see that this is the different the reactions, different stages of your temperatures. So but your delta S, as I have already written, so delta S is S of AO2 minus summation of S of oxygen, sorry, S of oxygen plus S of A. Okay. So now first case I told that delta S is already delta S is negative, so slope is delta S1. Let's say this is delta S1. Slope is positive. Okay. So now in the second case, what will be the delta S? Still, now what is happening? So S is for your gaseous, and now when you are above T1, so this A is melting and it is forming in the liquid form. Okay. So that means S of O2 that is in the solid form, but S of O is also in the gaseous form, but your S of A is in the liquid form. So what will be the slope delta S sign? Still it will be positive, sorry, negative, because this side it is solid, right? This side is solid and this side it is gas plus liquid. So still delta S will be negative. But what will be the value? Delta S2. Let's say write it delta S2. So what will be the value? What will be the value of delta relation between delta S1 and delta S2? Is it greater than, or is it less than, or is it equal? Which one will be there? What is the relation between this delta S1 and delta S2? You can see from these two different reaction, different equation 1 and 2. So only difference is that now initially it was solid form, now it becomes liquid. So when it is becoming A is becoming liquid, yes, delta S2 will be more negative. Is it? So what is happening? Now it is becoming liquid, right? This side is not changing. So this is not changing. Only this part, what is happening? It is increasing. The total sum of this part is increasing. So let's say earlier, let's say it was 8. Okay. Means let's say it was for this, it was, let's say 6, and for this part, it was, let's say 2. Just I'm giving some values randomly, like just so that you people can understand. Okay, so now what is happening, this everything else are almost similar, little bit value maybe changes because of the change in temperature, but drastic change will be there when it is transferring or converting, transforming from solid to liquid. So in this case now it is in the liquid form, so now the entropy of this liquid will be much more higher than these values. Okay, so that means this side, this value is increasing, this total sum is increasing, so delta S2 will be more negative. Okay, so delta S2 will be more negative. Delta S2, okay, so that means your slope will be more negative, or slope will be steeper. So now you can see in this case your slope is a bit steeper, but in this case your slope is not that much of steeper as compared to this. First here slope is higher, then here slope decreases, right? But in this case you can see here slope is this much, and then suddenly slope increases a bit more. So now I think up to this part only you can answer, because so as you have seen that delta S2 is more negative, so that means slope of in the second part will be more steeper than the first part. So that means this is the correct answer, right? In this case your slope is more steeper than the this part. And what will be in the third case, by the way? Let's say maybe one option was there almost similar to this thing, but in the first cases it was like this, and then it may shows more steeper than this. Then you also have to see what will be the third cases. So in the third cases also, if you see, so now what is happening, sorry, so in the third case delta S3 is S of AO2 in the now it is transforming into liquid. Okay, so now also this value is changing. Okay, so that means now also this got some positive means some significant value as compared to this. So in this case delta S3 is maybe the less negative, it is less negative than delta S2, right? Because now this part will change only because of the temperature effect, but in this part earlier it was solid, now it transformed into liquid, so suddenly this the value of this S of AO2 will increase. So as the right hand side entropy is increasing, so that means that your total entropy change will be less negative as compared to your delta S2. So that means slope will little bit it will decrease again, as you can see. But in this option you can see slope was increasing from this part. So you can clearly mention that this is not the correct answer. Correct answer is option C. So understood, or do you people have any other doubt? Okay, so now we can understood, right, how to approach the question. So always you should go step by step. Okay, so first you find out that the slope is positive. In all the cases slope will be positive or delta S is negative. So that means at the very beginning itself you can cancel out these two options. So now you have to play with these two options. Okay, option B and option C. So now we will find out what is the difference between option B and option C. So only difference in the terms of slope. Others it is almost similar. G is increasing with temperature, right? So only slope is different. So as soon as you find out that slope is different, so you have to think in that direction, like in the direction of your slope. So then you will find out how the entropy is changing with different temperature ranges. Okay, if you think in the step by step and if you go in that direction, automatically if you give some time you will find that answer. Okay, so okay, so as it is clear for everyone, so I'll move to the next question. Hmm. Okay, so this is the question number 43 of GATE 2017. The question is, for homogeneous nucleation of solid in a liquid of a pure metal, the critical edge length of a cube-shaped nucleus is. So that gamma value is given, surface free energy or surface energy, and the volume free energy is given. So any one of you want to approach how we can calculate the critical length of a cube-shaped nucleus? I think in my earlier session also I have covered this kind of questions, but the only change is there. There it was spherical shaped nucleus. Now it is mentioned that you have a cube shaped nucleus. Okay, so how to approach? Okay, 2.52 nanometer. Okay, okay. So let us solve this question. Okay, so it is mentioned that okay 4 gamma by delta GV. Others are also getting the same equations or not? Have you people tried, or should I wait for some times and then I will start answering? Okay, you are also getting same expression. Yes. So when your nucleation process is happening, so basically your liquid is transforming. Let's say this was liquid initially. So when it is in the liquid, what happens? It means within a small range, it always forms some kind of solid-like cluster, and it always destroyed when you are at T greater than Tm. But as soon as you come down at t less than tm, what will happen? This solid like cluster that are forming in the liquid phase, so that will be stable. Okay, so the critical nucleus is like it is the smallest nucleus which is which will be stable if further atoms is added to it. Okay, so this is the smallest stable size of the size of the your nucleus. So this is the critical nucleus. Okay, so now what are the two driving force? What is the driving force for this? Driving force is your delta gv, the change in your free energy. Okay, so let's say this is the free energy change, this is the g versus t. So in the first question already you have seen how the g versus t curve should look. Okay, so let me use a different color. Okay, so this is the your melting temperature tm. So above tm your solid is liquid is stable. So this is the g of liquid, that means liquid is stable, that means the g of liquid is lower than the g of solid, and this is g is solid. So when you are going at below tm, what is happening? Your solid uh, del g of solid is lower than your g of liquid. So this difference is delta gv. So this is giving you the driving force. Okay, but one opposing factor is also there. Opposing factor is when this kind of cluster or this nucleus is forming, so everywhere else you have liquid, but at the it is forming a solid like of structure, so you are creating a new interface. So this is solid liquid interface, and because of creation of the new interface it also requires some energy. Okay, so you have two energy. So first, so the resultant you can write as delta g for nucleation, or delta g delta g for homogeneous nucleation. So first one is the your driving force. So driving force is equal to volume into your delta gv, and this will be the negative value. Okay, delta gv value is negative, and then your other opposing factor is area into your free energy, surface free energy or surface creation energy. Okay, so now in this question it is mentioned it is a cube shaped nucleus. So for cube shaped nucleus, what will be the volume? Volume is a cube, and surface area. Surface area means total surface area. So total surface area you have total 6 surfaces, right? So 6 times of a square. So it is 6a square. Okay. So now you can write delta G homogeneous is equal to a cube into delta GV plus 6a square into gamma s or gamma. So now for critical nucleus, what will happen? So let me draw that graph also once again. I hope you people know this, but still. So one is that negative part that is related to delta GV. So it is also, this term is also proportional to a cube, and this is proportional to a square, right? Two term was there, this first term and the second term. Okay, so what will be the resultant? Your resultant will be, will look something like this. And this is the critical length of the your critical nucleus. So this is a star. So you can see when you are adding one more, if you add one more atom, so your free this resultant delta G homogenization will decrease, right? So let's say if you add one more atom, it will still decrease further. So that means after this it is stable. If you somewhere here, let's say you are here somewhere here, so then if you add one more atom, your free energy is increasing. That delta G for homogenization is increasing. So that means this is not stable. So only after this point it is stable. So basically this is your maxima for this curve. So for this you have to differentiate that d of delta G homogeneous by, with respect to a you have to differentiate, and it will be equal to 0 for this location or for your critical size. So what will be the d of delta g homogeneous values? It will be 3a square delta gv plus 12a into gamma is equal to 0. So now you can write as a is equal to 12 gamma s by 3 delta gv or 4 gamma s by delta gv, right? So this is the expression you should get. So now we can put the values. The gamma is given 0.177 joule per meter square and delta gv is also given. How much it was? Minus 2.8 into 10 to the power 8 joule per meter cube. So now we can calculate. Sorry, this will be a star because critical nucleus we are considering this one, right? So now your a star will be 4 times of 0.177 divided by 2.8 and here it will be minus. So minus 2.8 into 10 to the power 8. Okay. So if you calculate, you will get 2.52 into 10 to the power minus 9 nanometer. Sorry, meter. In nanometer, it will be 2.52. So I hope every one of you are getting the same answer. If anyone has any doubt, you can ask me. Clear? Okay. So now can you people tell me what will be the expression for delta G homogeneous star? What will be the expression for this? Simply just you have to put the expression for A star here and you will get that expression. Okay. So okay, let me also show this thing also. So like sometimes in the questions they might give different shape of your nucleus. So that time you have to be very careful and derive that expression like accordingly. Okay. So delta G star of homogeneous nucleation will be your this reaction this equation you have to write. So it will be A star cube into delta GV plus 6A star square into gamma. So now A star value we already have calculated. It is 4 gamma by delta GV whole cube into delta GV plus 6 into 4 gamma by delta GV square into gamma. You will get 64 gamma by delta GV square, right? Plus 16. How much it is coming? Okay. Okay. Gamma square, right? Gamma cube delta G P of square. So if you take the common of 64 and 96, okay, let's take 64 as common. 64 gamma by delta GV square. So it will be 1 plus gamma square delta GV and the ratio will be 96 divided by 64. How much it is coming? T by 2. So this will be the expression for your. I think for the cubic shape, this expression should come. First expression also contain gamma cube. Yeah, yeah. So that's why I was thinking. I am making some mistake, but thank you for pointing me out. So here also it will be gamma cube, right? And this delta g cube, delta gb cube into delta g, it will, yeah. So gamma cube and gamma cube here. So just it will be added up. So almost 64 plus 96, right? So now okay, so if in that question, if it was asked that calculate the delta G star for homogeneous nucleation for a cubic shape nucleus, so then you have to use this expression and you have to calculate. Okay, so in general, which type of nucleus generally form? Mostly we consider it spherical. So why you consider it spherical? Yes, right. So spherical nucleus basically it has minimum surface area, but if you think in terms of crystallography, like in terms of crystallography, we have 14 Bravais lattice, right? So if you combine any of those, it it is not possible to form exact spherical shape nucleus, right? So, but then what should be the uh, nucleus shape which will give you the uh, minimum surface area? So that is actually proposed by Kelvin. So if you combine the 14 Bravais lattice, you will never get exactly spherical shape, but that Kelvin proposed that there is some kind of structure that it is possible, which is contained around 14 faces. Okay, so eight of those are hexagonal and six of those are square, or square is not exactly square, like tetrahedron kind of, like four faces, four side will be there. Okay, so this kind of shape is called as tetrachydecahedron or Kelvin shell. So this kind of, it is observed that this kind of shapes gives the minimum surface energy. Okay, okay, so I hope it is clear for everyone of you are clear with this question. So now let me move to the next question. Okay, this question is also related to the previous question or previous derivation also. So the question states that the critical value of the Gibbs energy of nucleation at equilibrium temperature. At equilibrium temperature means at T is equal to Tm. What will be the delta G star for homogeneous or for heterogeneous also? So let us consider for homogeneous only, because on both will be same. So what will be the delta G star for homogeneous when T is equal to Tm? What will be the answer? So if we take the reference from the previous derivations also, okay, you are saying positive. Okay, so now let us see the, so as we have already derived that thing for based on the cube shaped nucleus, so I am writing in that terms only. Okay, so it comes around 164 or something 60, 160 gamma cube by delta g v square, right? Now it is given at equilibrium. That means your T is equal to Tm. So now I also have drawn that delta G versus T, G versus T curve. So this is for solid, sorry, this is for liquid, and this is for solid. Okay. So now you are at T is equal to Tm. That means you are at this temperature. So at this temperature, what is the value of delta Gv? It is 0, right? Initially, when nucleation was taking place, that time we were at this temperature where delta Gv is negative. But now we are at this temperature. So delta Gv is 0 here. So what will be the critical value of the Gibbs energy for nucleation then? Now it is clear, right? What will be the answer? Yes, exactly. So it will be infinite because your this part is 0. So if this is 0 means, so your it will be infinite. So your correct answer will be option B. Okay. So now next question is also related to this concept only. Now let us move to the next question. So the question is, the melting point of a metal is 1356 Kelvin. When the liquid metal is undercooled to 1256 Kelvin, the free energy change for solidification delta G liquid to solid is given, that is minus 1000 joule per mole. On the other hand, if the liquid metal is undercooled to 1200 Kelvin, the free energy change in joule per mole for solidification is. So this also we can approach from this free energy versus temperature plot. So G liquid to solid means basically G delta GV, which we were writing, not exactly delta GV, like delta GV is per unit volume, and in this case it is like per mole, not per unit volume. Okay. So but from the graph only it is like it is same. So there you have to divide that part. Yeah, you have already calculated. Yes, it is minus 1560. So basically this is the TM, say liquid and solid. Okay, so the melting point is 1356. So this temperature is 1356. So at 1256 it is given. So at 1256, this temperature is, let's say, 1256. Here that delta G value it is given minus 1000, and what will be the value here? Okay, at 1200. So the equation is like your delta G liquid to solid at your melting temperature, it will be uh, delta H m minus Tm delta H, delta Sm, right? So now at melting temperature it is 0. Now at some other temperature, let's at below Tm, it will be delta G at that temperature, liquid to solid at that temperature is equal to delta H of m minus T delta S of m. Okay. So from here you can get that delta Sm is equal to delta Hm by Tm. So your equation that will be delta Hm minus T by Tm into delta Hm. So if you take delta HM common, it will be 1 minus T by Tm. So Tm minus T by Tm. Okay. So that two temperature you have. So at one temperature it is minus 1000 is equal to delta HM into delta T. So delta T is in this case 100, right? And divide by Tm. So this you don't know. 1200 is equal to delta HM into 156. Yes. So now if you take the ratio of these two, how much it is coming? Till minus 1000 so this will be the your correct answer. So yes, Kamesh, you have given the correct answer. So it was a numerical answer type question. So correct answer is 15 minus 1560, 1560. You have to write the unit also like joule per mole. Okay. So now I have one question. Like you can see the delta G at temperature T also. Here I have write this as same delta HM and minus T delta SM. Do you know the reason? Because when T is changing, your delta HM and delta SM, it should not be the almost same value at the melting temperature, right? So the thing is that it is assumed the same value because let's say at delta at G at temperature T, it will be basically H of T minus T into delta S of T. Now, if you know the Kirchhoff law, so from this we can write delta H at T is equal to H delta H at your melting temperature or at fusion temperature plus integration of T from your melting to temperature at which you are doing the undercooling delta of Cp into dt, right? So now what is the delta Cp? Delta Cp is your Cp of solid minus Cp of liquid at temperature T, which is below your Tm. Okay. So as temperature T that is below your Tm, so that's why it is very difficult to calculate the value of Cp at Cpl at temperature which is below Tm. Okay. So that's why you cannot calculate the delta Cp value or you cannot calculate the Cpl value. So that's why it is difficult to calculate the Cpl value. So you cannot calculate the delta Cp value. So exact value of your delta Ht you cannot calculate at your temperature T, temperature of undercooling. So that's why it is assumed that delta Cp is 0, and if you assume delta Cp is 0, so then delta H of T is equal to delta H of M. So similarly, delta S of T is equal to delta S of M. Okay. So that's why it is assumed that delta Cp is 0. So for this, the temperature T also you can write is it as delta Hm, and then we'll get that equations. So is it clear? So everyone are okay with this? So two more question I had. So if you people have time, so I can also solve these two question also. So as tomorrow, not tomorrow, in the next session, I will be covering the concept of the regular solutions and all. Regular solutions, free energy versus composition diagram, miscibility gap. Okay. So initially I thought I to cover this question on that day only, but it will be better if I. This is a like simple question. I think every one of you know this thing. So, so the question is, this is the question number 48 of GATE 2015. So the question states that configurational entropy due to ideal mixing in a binary AB system is expressed as delta S mix is equal to minus R XA ln XA plus XB ln XB, where XA and XB are more a mole fraction of A and B respectively. So when delta S is maximum when XA is equal to, so how to calculate this thing? I think without calculation also I think you people know the answer. So let me just show you the derivation of this thing also. So then yesterday I will cover the concept of regular solution. So there these things will be required. Like, so when delta S is maximum, so delta S is maximum, then you have to take derivative with respect to XA, right? So now if you write this, you have to write this equation in terms of XA. By the way, all of you know the value, right? Yeah, zero point 0.5. So XA ln XA plus 1 minus XB ln of 1 minus, sorry, 1 minus XA ln of 1 minus XA. So now if you take the differentiation, it will be minus R bracket XA by XA plus ln of XA, then minus of 1 minus XA divided by 1 minus XA minus of ln 1 minus XA. So now this thing and this thing will cancel out because this is plus 1 and this is minus 1. So it will be minus R into ln of XA by 1 minus XA, and this is 0 at maximum, right? So this is 0 means your XA by 1 minus XA is equal to 1. That means 2XA is equal to 1, or you can write XA is equal to 0 0.5. Okay. So at 0 0.5 it will be maximum. Okay. So what happened? I don't know why this writing got removed actually. Okay, so at 0 0.5 it will be maximum. Okay, and the graph if you plot, so let me plot here. So it will be in the minus R, so in the negative uh, so XA is always less than 1, right? So this part will be negative. Okay, ln of x will be negative, and there is also minus R is there. So this will also be negative, so it will be in the positive direction. And if you plot like t into delta s, then it will be in the negative direction. So now if I plot only delta s mix, it will be something like this, look like this. Versus composition with XA, and at 0 0.5 it will be maximum. Okay, so in the next session I will show how the delta G versus X plot looks like, and how we were getting this kind of plots, and how the equilibrium when two phases will be equilibrium, when it will form miscibilities. So that concept will also I will cover in the next session. Okay. So okay, so now let us move into the one very simple questions. So this is the last question of today. So the question is, a species can diffuse through the lattice. So diffusion coefficient is dl along grain boundaries also. In that case, diffusion coefficient d of g grain boundary, and along surface, free surface. In that case, diffusion coefficient ds. So which of the following relation is correct for the this diffusion coefficients? So what will be the answer? Option D. Yes. So surface diffusion through the surface is highest, and then diffusion through the grain boundaries, and then diffusion from the through the lattice. And the reason is because your surface is the more open structure, because at the surface uh, you have the broken bond there. So it is like at the free surface it is very open. So their diffusion rate is maximum, and then at the grain boundaries it is like a cluster of dislocations and these things. So it is more open structure as compared to your lattice. In your lattice the atoms are more closely packed, but in the grain boundaries you have more voids and or more open defects is there, more open structure it is. So that's why diffusion through the grain boundary is more as compared to diffusion through the lattice. So in this case the correct answer will be option D. Okay. So I hope everything is clear which are covered today. So we'll meet on the next Sunday again, that is on the 15th of January. Okay. So please note down the time. It will be from 5 p.m., not from 6. Okay. So it will be a 2 hours of session. So do you people have any doubts or anything? Okay. 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 So we'll meet in the next Sunday then.